Welcome Algebra. This is section 1.6, use precision and measurement. So basically, get detailed. Alright, I can compare measurements for precision. I can use precise measurements in real life situations. Alright, so here we go. 1 foot is 12 inches. Ooh, 1 pint. How many pint is how many ounces? I'm going to leave this up to the first person who can tell me gets a gong. Some of you might have to look it up. Alright, key concept. Well, if we look at these two tape measures, this one is broken off by inches, and then we have a ½ inch, a quarter of an inch, and an eighth. But if you look here, they broke that down even further. So this one is definitely a lot more precise. Sorry, I'm going to use red pen so you can see it. And how about here? This does have a second hand, and this also shows a second with the clock. So that could be argued, but you see in between every second. So your analog clock is actually going to be a little bit more precise than your digital, unless this can get into smaller units. So this one could be argued. They're both showing seconds. This is 36. This one, you can hardly see that little second line, but if you argue saying, well, this one you know exactly when the seconds change, this one you're kind of guessing it when you see it, so every angle would be different, then you could say the digital one. How about this? This is kind of like, let's say this is a musical wavelength, and digital recordings is actually a series of blocks, whereas your analog will actually be a smooth curve. That's why some people actually like records better than your digital music. So they're recorded via analog, whereas digital, they might hear this little gap or hear some extra here. I can't hear the difference. I'm not that strong, but again, some of your record enthusiasts will definitely prefer a record player versus any type of downloaded music. In any case, let's look at example 1. So compare the precision of measurement. Which one's more precise? The liters are more precise. 1.79 liters is more precise because we have an additional decimal point. It's more detailed. This is 1.80, but this is 1.79. So it goes to the nearest hundredth place. How about this one? They're both in feet. This is the same as 3.25 feet. And this is the same as 3.2 feet. So you can argue that this one's actually more detailed because it went to an additional decimal point. But how about this one? 1 meters. Then you have like 2 meters or 3 meters, whatever. This is in centimeters. This is a smaller unit. Smaller unit will also be more precise. All right, significant digits. I don't want to say they're not important. It becomes very important, especially when we're using scientific notation. Hopefully that'll come up soon. But significant digits, this confuses a lot of people, and even high school students. I have some examples here, and then they also have the rules. And according to this number, all these digits are significant numbers. When you should get worried is if you see a 0 somewhere, and then there are special rules. But this one has all significant numbers, so all 6 are significant. If you have numbers in between a decimal and a number other than 8, those are considered insignificant. But anything after would be significant, because those two digits, just the 8 and the 0 after, are significant. If you have numbers in between, zeros in between two non-zero numbers, then you count all of them, so you have 4. So if you look closely at this little picture here, I wonder if does that help? Let's try to zoom it. These right here are not significant. Do you see how it says not significant? These two digits are significant, and so would be the values after. So this would have these 4 significant digits, this one. Right here, a 0 in front of a decimal is, for, as they say, cosmetic purposes. You'll see me a lot of times not write them down. I would say it's more politically, mathematically correct to put that 0 in front of a decimal, but it's not necessary. Zeros in front of your first non-zero number. These are not significant. You don't need them. All of these are significant. And the ones after. So all of this, like in pink, you don't have color on yours, but basically the 4 and then to the right would all be significant digits. You can look at more examples. I got these from Google Images. So if you look at Google Images, type in significant figures, you'll see lots of different examples. And you can even say significant figure examples on Google Images, and you'll see them. All right, so let's do some examples here. Oh, I have more rules. Let's go to the top. Actually, I'll go back up. I'll zoom out a little bit. Look at these. It's another box of rules. I didn't pay attention to see if that printed for you well. I hope it did. But it just gives you some more examples. So let's look at example 2. Determine the number of significant figures. Okay, right here, I have 2 non-zero numbers, the 2 4s. So we're going to count everything in between. So there's 5 digits there. We have 5 significant digits. And again, significant digits are important, especially when we get into scientific notation. So we'll be using it then too. All right, how about this one? Remember, this is our first significant digit, and then anything to the right. But the 2 zeros in between the decimal point and the 2 are not significant. Again, wait until we get to scientific notation. So I have 4 significant digits here. I'm abbreviating these. Hope you're okay with that. Now this one's a tricky one. You'll notice it when I put this number into scientific notation later on, and you'll see why. But this is my only significant digit. So there's just one significant digit here. All right, rules for calculating. If you're going to be adding or subtracting, add them up like you would, and then you're going to round the answer to the least number of significant digits. So if I look at these 2 numbers, this has 3 significant digits here. So your final answer has 3 significant digits. When I'm subtracting, this one has 3 significant digits, and this one had 4 significant digits. So when you subtract, do it as is, and then round it so you have 4 significant digits. Sorry, this one had 3. That has 3. Remember, you're not counting that 0. Not counting these 2 zeros. When you multiply, it's the same rule. You're going to multiply the numbers as you would, and then round to the nearest significant digits. So we have to round this. This has 2 significant digits. That one had 3, so round it to the nearest 2 significant digits. Same with dividing. Divide as you would, and then round to the least amount of significant digits. All right, so let's add these 2 up. I'm going to add them up as I normally would. 21.6 plus 29.77. Let's see here. 7 plus 6 is 13. Carry the 1. 51.37. However, this has 3 significant digits. So I've got to round this so I have 3 significant digits. This will round that up. So 51.4 is going to be your answer. Multiply these. 3.9 times 5.17. I'm going to use my trusty calculator. 20.163. All right, now this one actually has a tricky issue. I have 2 significant digits here. So I have to round this so it has 2 significant digits. But if I round this so I have 2 significant digits, this 163 is not going to bring that to a 21. So if my final answer is a 20, this only has 1 significant digit. So this one is pretty crazy. If I round the 6, bring the 6 up to a 1, bring that 6 up to a 2, this has 3 significant digits. How do I get it to be 2 significant digits? So that's where you could run into some issues. I would accept either case. I'd probably lean more towards this one, but definitely either case, because I usually want to go to the least amount of significant digits. Okay? But we can't get 2 out of that. So here's your homework assignment. We will be doing this in class. Keep cool. Hopefully all of you had a really good Labor Day weekend. Sorry I didn't really ask you about it. I'll see you tomorrow. Bye.